Okay, hello Math Counts friends. Today is part 2 of my geometry series of geometry fun series, I should say, of Math Counts problems. I'm going to be looking at angles in a circle. If you didn't see part 1, I'll put a link in the description so you can go back and check that one out first before you get over to this one. All right, so let's take a look. So the first thing we're going to do is we're going to draw a circle. And I'm going to teach you about some properties of a circle. Let's say you take two random points on the circle, here and here, and you draw the angle that is formed. If you draw the radiuses from the center, you draw the radiuses out to those 2 points, that will give you some angle. And if you take another point, which is a point on the circle, it doesn't matter where you take it. Like for example, we could pick this point here. You could also draw the lines that come from that point to your first 2 points, and that will give you another angle here. Okay. So the property I want to teach you is that the angle that's formed here, theta, is half of the angle that's in here. So this one would be 2 theta. Okay, so if you have some angle here, it'll be twice as much. And it turns out there's a lot of interesting things that follow from that assertion. The first one is that it doesn't matter which point you pick. Like for example, I could pick another point over here, and I could draw those 2 lines. Whoops, that's not very straight. I could draw those 2 lines from here off to my 2 points, and that would also be theta. And you could pick another one wherever you want. You could pick one over here. You could draw the 2 lines that connect that point, and that would be also theta. So I guess, yeah, I mean, there's a lot of, I think there's kind of some fun applications of this. For example, if you're sitting around a round table and you have something that everyone wants to look at, you can put it here on the edge of the table, and everyone will see it at with the same angle of their field of view as long as they sit on a circle. So that's kind of fun. Another thing is that there are some special cases. So for example, we could move this point all the way until it gets right up next to one of the original points, right? So let's say we move it as close as possible. In fact, we can take the limit, and that's an advanced concept there, but you can take the limit as this point approaches that point, and what you'll end up with in the limit is you'll end up with a tangent line. A tangent line is a line that intersects the circle at only 1 point. And so that property is still true as this point gets closer and closer and closer and closer, staying on this side of that point. And what you'll find now is that you have an angle formed here between those two. Well, I didn't draw a very straight line across here originally, but maybe I can fix that. So you have this angle that's the angle between the tangent at one of the points and the line to the other point. And it turns out that that will also be theta, right? So half the angle from the center here. And so that is a useful thing to know as well, that the tangent is always going to form an angle with this line that is half of the angle you would get from the center. One other thing that follows from this is, what if you choose 2 theta to be 180 degrees? Well, okay, before I get to that, I want to say one more thing, and that is that I said you could pick this point anywhere on the circle, but something interesting happens if you take the point and you go all the way to this other side over here. Now the angle you form with this is bigger, okay? And actually, that bigger angle is half of this other angle, 360 minus 2 theta. So let's put this one is 360 minus 2 theta. And this bigger angle here is going to be half of that. So that'll be 180 minus theta. Okay? And yeah, okay. So yeah, so if you pick your point anywhere on this part of the circle all the way around this way, you'll get that theta angle. But if you pick your point over here on this little arc here, you'll get, you know, your corresponding angle will be here. And that makes sense because instead of thinking of this angle as sort of looking at the, like say you did have a TV here, right? Instead of, or some other object, I mean, instead of looking at it from one side, you're looking at it from the other side. So you're no longer looking at this arc here, but you're looking at this bigger arc here, because you're looking at it from the other side. Okay, so hopefully that made sense. But I want to talk about a special case where 2 theta is equal to 180 degrees. So let's go ahead and erase this. We'll draw that special case here. So let's go ahead and grab a new circle. Grab a new circle, and we're going to draw a diameter through the circle. So hopefully that's pretty close to a diameter there. So what that, if it's a diameter, then it includes the center of the circle. And that means I can look at this angle here. This angle is 180 degrees. And so now it doesn't matter whether I pick my point over on this half or I pick my point on this half. When I draw that angle, it's always going to be a right angle. It's going to be half of 180 degrees. That's a right angle there. If I picked a point really close here and drew this one would be a right angle as well. And yeah, not only that, but yeah, whenever you have a right triangle, if you draw the circle in which it fits perfectly inside, you'll find that the hypotenuse always contains the center of the circle at its midpoint. So that's kind of a cool property, and that's very useful in a lot of math counts problems. You'll find that knowing that that this is a right angle when you have a diameter comes in handy quite a bit in math counts problems. Okay, so that's the end of part 2 of Geometry Fun. I hope you guys enjoyed that, and what's going to come up next actually is the power of a point proof. And or power of a point. I'm going to teach the concept first and then I'll give you the proof, so you can stick around to see the proof if you want. But the thing is, the proof relies on these first 2 videos. So it relies on the cyclic quadrilateral supplementary angle theorem, as well as this property of circles and inscribed angles. So look forward to seeing you guys in the next video. All right, hope you're having a great day. Goodbye.